Okay, Kickstarter update number 3. In this update, we are explicitly focused on the dashboard performance, which cannot be fixed with caching, which is why we're focused on it. Compared to the front end, something like blog posts or a homepage, which can be somewhat solved with caching. We're going to demonstrate 5x speedup and also 5x lower latency. Recording this on January 21st, 2026. Alright, first we're going to do the demo on my laptop, and then we're going to do a demo on a real user server. Real user server, we only get 3x for some reason. Kind of annoys me. Anyway, on my laptop, I configured this with one Apache worker. It's easier to test, lower variation for requests per second, and also much easier to measure latency. Because otherwise you'd have to, the tool is measuring latency across all requests, across all workers. So with one worker, this becomes much easier to measure. All right, I'm going to demonstrate this now. Let's go over to the terminal. All right, this is, I guess run this now. Okay. 300 requests, one concurrent, one worker on WP admin. Okay, 32 requests per second, and we get 31 millisecond latency. That we have here, roughly the same. Okay, now I'm going to update to the latest and reinstall. Okay, great. Rerun this benchmark. Okay, 151. Latency 6.6. So you can see it's around 5 times lower latency, around 5 times more requests per second, approximately. Okay, that's my laptop. Now this is on a real user server. We only get 3 times speed up. Kind of annoys me. I have a theory this is due to Docker virtualization on Mac, file system being poor. So we do a lot of optimizations on file system access. So for specifically a Docker on a Mac, the file system access should be much improved. Anyway, so or Lightspeed is doing something. That's the other theory. Anyway, so here's the server environment. Configure with 60 workers, not one. I tried configuring it with one, just could not get it to work. It just kept hanging. The benchmark would not complete. It would complete like 98%, and then the last couple of requests, it just hangs. It just does not complete. I don't know why. I think something to do with Lightspeed. At any rate, I just configured it to 60. We're going to see a lot more variation in the requests per second, and also the latency. General ballpark is around 3 times speed up. All right, I will demonstrate this now. All right, so same idea. The script. This time I have it for 200 requests. Concurrency level of 5. All right, get 66. Usually not that fast. Try it one more time. It's just hanging now. 50. Okay, anyway. There's just a lot of variation. TM, this is short for Tachyon Manager. More on that later. Okay, we're going to enable the extensions now. Okay, let's go rerun this benchmark. So much faster, 161. Now, 170. 186. Can't get 186. Whatever. It's around 3 times faster. Time per request 31. What was it before? Whatever, you can look it up later. Anyway, so those are the demos. Alright, let me go over now. How do we achieve the speed up exactly? I'll discuss at a high level how we did it. There are around 4 things we did. The first big speed up, we found we could optimize away this database to exactly 0% of request time. Exactly 0%. There's no need to touch the database, no need to talk to the database. Um, in the vast majority of dashboard loads, these SQL queries are nearly all read-only. Alright, so these can be cached. Even if it's for a time to live of only 30 to 60 seconds, they're mostly read-only. Okay, and some of these are SQL queries where it's okay to have stale data. For example, there was one SQL query where it was just counting the number of comments. Okay, does that really need to be real time? Is it mission critical? You can just attach it. You can cache it for 30 seconds. Okay, you don't need to. It does not need to be like up to the second up exactly correct. So with nearly all the queries cached, there's no need to init a MySQL connection. Which raises a big question for why doesn't WordPress do this earlier? Because there's quite a lot of users using Redis, which is an in-memory database, specifically for the purpose of caching read-only SQL queries. All these Redis users are still paying the cost of this MySQL connection that's being initialized. Even if all the SQL queries were read-only, even if all the SQL queries hit the Redis cache, you're still initializing the MySQL connection. So this is kind of the first sign to me that WordPress is not that serious about dashboard performance. Because this is a very easy win. You just lazy init the MySQL connection. And if there are no SQL queries that need to be made, then you do not, that's a big speed up win. You never ever need to touch the database for the vast majority of dashboard loads. So that was pretty cool. Pretty cool. We didn't even need to touch the database. Second one was we did a lot of rewriting from not only from PHP to C, but also from PHP to assembly, which is another level beyond C. Specifically SIMD. For example, I'll give you one big example. There was many code paths where WordPress is trying to the security scanning text for invalid tokens. Okay, and so they're using a bunch of regex for this, like preg match. However, we can rewrite this in hand-tuned assembly, specifically SIMD, and get approximately 16 times speedup. SIMD is where it allows for like crazy parallelization in the CPU. Okay, so here's the third one. This one's pretty crazy. This was specifically for a feature where they're doing some sort of custom font face generation. And my big question is, what percent of users are using custom fonts? I bet you it's not more than 1%. But this custom font face generation was taking up 25% of request time. So just caching this one feature, because like these are font faces, okay? We're not even talking about CSS. These are just fonts. They're going to be the same, like 99% of the time. You just cache it. Okay, and that was like 25% lift. That one was real crazy. And this is another sign that, like, just not that serious about dashboard performance. Okay, let's do the fourth one here. This is a very legacy feature that's still around in WordPress. WP cron introduced in 2007. They're kind of trying to mimic what a real cron job does, which is like which is basically a scheduled. You run code on a schedule, whether it's every hour or every minute. And every dashboard load kicks off a cron job. That to me is a little crazy. You don't need to do that. You should just replace it with a real cron job scheduler. Just assume you have access to some sort of cron job. This was making the dashboard load quite slow. I'd say around a 10% hit, or approximately 10%. Alright, so that's what we learned about WordPress performance. Here's the software downloads to expect. It's a TM, which is short for Tag Account Manager. We're modeling this after a Node Version Manager, which is a popular way to download and maintain Node versions. Okay, you run tm install, it downloads C extensions. But it just a real easy way to download or to manage tag conversions. Okay, and last but not least, here call to action. Anybody interested in testing? Only Kickstarter backers will be allowed to test. Here's a Discord invite link, or email me, etc., etc. All right, hope to see you soon. Bye.